In this video, we're going to look at savings annuities. So with these types of accounts, what you'll have is you are building interest, and it's building interest on an account that you're depositing regularly into. So with this, you want to keep in mind that you're depositing money. So with that, we have an account that's growing. And when you deposit the money, it's done on a regular basis. So regularly. And with that, you choose if you're depositing every month, year, quarter, daily, hourly, things like that. So what we want with this is we want to find the balance of our account. And we can have an idea of, like, for example, if I know I want to have a certain amount of money in a few years, I want to figure out, like, how much savings should I put aside each month? If the bank gives me a certain annual percentage rate for growing interest, I can put these pieces in to measure the balance of the account. So there's a lot of variables here that we've seen before. I know this is a big scary formula here, but it's all about just getting the pieces and plugging into the correct spot. And then it's also really about plugging it into the calculator correctly. So just as a review of our variables. So A is representing the amount in the account. So that's our balance. And this variable D is new, and this is our deposit amount. So that's how much we'll be putting aside each month, year, quarter, whatever we're doing. R is the rate. Again, when we plug in rate, it should be in decimal form. And then N is our number of times that we deposit per year. And then T is going to be the amount of time that's passed. So that'll be time, which is typically the number of years that have passed. So let's look at some examples with this, and I'll show you how to plug into the calculator as well. So we're going to have a traditional individual retirement account, and with this, it'll be exempt from taxes until we withdraw it. So what they'll do is we'll decide how much we're going to deposit, and in this case, we're going to do deposits each month into this IRA with a 5.6% interest. And then we want to know how much will we have after 20 years. So just to get our variables here, is that $50 each month, that's what D would represent. So we're depositing $50 each month, which if we're depositing monthly, then that determines N. So we're putting some aside each month, so that'll be 12. We have our rate of 5.6%, which would be a 0.056. And then how much will we have after 20 years? So that'll give us T, which is 20. So to calculate, we're going to be plugging in. So I'm just going to take my values here off to the left and plug in accordingly to the formula. So we'll have 50 and then two sets of parentheses, 1 plus the rate over N with an exponent of N times T, and then minus 1, close parentheses, and then the denominator will have the rate divided by N. So just plug in the correct numbers into the correct spots. The tricky part will be plugging it into the calculator correctly. So again, I highly recommend the online calculator for these, especially since you can separate the fractions in a way like how you see in the formula. So I'm going to use this button for A divided by B to separate my fraction, and then I'll type it in pretty much exactly how I wrote it, 50, two sets of parentheses, 1 plus, and then I'm going to go ahead and make a second fraction in there, so the 0.056 over 12, and then you want to close those parentheses, and then we want an exponent, and this is the only spot where you'll have an extra set of parentheses to make sure both of those pieces stay up there, so the 12 times 20. So close the parentheses around that exponent, and again you can hit the right button and that'll drop you down so you're out of the exponent, and then we'll have a minus 1 and close parentheses. And then the denominator will have let's go ahead and plug in parentheses there just for matching our form, and we'll have 0.056, denominator of 12, close those parentheses, and there is our answer. So rounding this, actually this is going to end up rounding to a whole number. If we try to cut at that second decimal place, the 9 would round up to 10. So we'll have a extra 1 there, so that'll be an 8 at the end. So with that, we get $22,038. And you can go ahead and just do a quick mental check if this makes sense, like $50 over 20 years. If you're putting that aside, does that make sense that it would come out to $22,038? You could even see like how much money you would have put into the account by taking 50 times 20. So if you take 50 times 20, $50 each month. Sorry, we need to multiply by 12 as well. So $50 each month for 20 years. Then what you could see with that is that that's about $12,000. And then building interest like this, especially 5.6% interest, is not too far off. So like maybe if this came out to like $5,000 or something really far off, you'd want to be careful of that. But this makes sense with a high percentage rate. We expect quite a bit. All right, so that would be the amount. Let's look at another form of problem where in this case it changes a little bit what we're going to solve for. So you want to have $170,000 in your account when you retire in 30 years. Your retirement account earns 7% interest. How much do you need to deposit each month to meet your retirement goal? So this question wants to know, what is D? How much do we need to put aside each month? So they're giving us the balance of the account. We know the time. We know the rate is 7%. And then we're doing this each month. So we know what N is, but we want to solve for D. So what this will look like is we'll have our 170,000 equals, we don't know D, and then we'll just plug in our other values following our formula. So divided by 12, and then 12 times 30, the minus 1, all over this 0.07 divided by 12. Now, for solving this, what I recommend doing is plugging in, and I'll highlight here what I'm going to plug into the calculator, everything on this right-hand side here. All of that can go into the calculator and will essentially give you a value that's multiplying with D. So I can fill in the blank for what could go in these parentheses here just by plugging that into the calculator. So let me go ahead and show you the calculator again here. So we separate our fraction, 2 sets of parentheses, 0.07 divided by 12, close parentheses, and then an exponent, and then just be sure to have those parentheses around the exponent, and then a minus 1, close those parentheses, and then the denominator, 0.07 divided by 12. So that gives you this number here. I'll go ahead and hit enter. So rounding here, and I said this in the previous video and I'll do it here again, with financial math in general, just try to avoid rounding as much as possible. For the sake of writing it on paper here, I'll just write that rounded value. Let's see. It was 1219.971. But the key is that in our next step, we're going to divide by that number. So we're going to divide by that 1219.97. Sorry, I wrote that wrong up there. And same thing over here. But when I actually calculate to get this final answer, in this scenario, it wouldn't be a huge difference, but it can in other scenarios. We're taking that 170,000 divided by, and then I want to use that answer from up above here. So what we can do is use the answer button so that it will copy and paste the exact value. So 139.35. So that'll be the amount I need to deposit each month. All right, let's look at another example here with another little twist on it. Something we're going to look at is how much is from interest. That's a new piece here. So we have this investment account. It's going to earn 3.2% interest. So there's my rate, 0.032. We're going to deposit $6 a day. So our deposit is $6, and then we're doing that daily. So N will be 365, and we want to see how much will you have after 10 years. And then we want to look at how much of that is from interest. So first let's figure out what we end up with. So our amount, so we'll have 6 and then parentheses 1 plus the rate divided by N, then exponent of N times T minus 1 divided by 0.032 divided by 365. And good thing watching these videos would be to try plugging this into your calculator yourself and make sure you can get the same answers out. If we do plug that in, that should be $25,808.36. Now, to find out how much was from interest, first thing we need to find is how much did we deposit in total? So to do that, we need to think about how much we've put in this account ourselves over these 10 years. So we did $6 a day. So in 1 year, I would have these $6 each day, and then we did that for 10 years. So overall, what we put into the account was $21,900. So if we wanted to know how much is from interest, what we could do is take the total amount that's in the account, so our balance, take that 25,808.36, and then remove how much we know we actually deposited into the account, and that difference will be the amount of interest. All right, this next page has some more examples, but what I recommend you doing is pause the video and try them for yourself first, and then go ahead and check your answers once you found some solutions. But this will be a good chance to try that, finding the numbers within the wording of the question, plugging into the formula, and then plugging into the calculator to get the answer out. Okay, so this first one, you want to save $110 per month, an annual rate of 7.8% interest. How much will you have after 15 years? So our deposit amount is that $110 per month. So that means N is going to be 12, 7.8% interest after 15 years. So with that, we'll plug into the calculator this 110, 2 sets of parentheses, 1 plus 0.078 divided by 12 with an exponent of 12 times 15 minus 1, all over that 0.078 divided by 12. So when you plug that into the calculator, you should get a grand total of $37,396.90. All right, and then this one is you want to save $30,000 for a down payment on a house, and you want to do this in 5 years. You have this annual rate of 5% interest. how much do you need to set aside per month? So we want to find what is our deposit amount monthly to get to this amount. So this is that case where we know the amount, we know the balance of the account. We'll want that to be $30,000 over a time of 5 years with a rate of 5% interest. We don't know the deposit amount, but we're going to do this monthly. So N is 12. So we'll have 30,000 equals D times 1 plus 0.05 divided by 12 to the power of 12 times 5 minus 1 over the 0.05 divided by 12. And then again, you'll want to plug in basically everything but D into the calculator to get a value. It should be about 68.0061, but try using the calculator for that exact value. And if we divide by that amount on both sides, then we should get a deposit of $441.14 each month. So these are savings annuities. We're going to see a formula in the next video that looks very similar, but the key to this is having an account that grows. You're depositing amount so that basically your money is growing. You're going to end up with more and more money that you can eventually draw from. What we're going to look at the next video is that idea of drawing from the account. If we're withdrawing on a regular basis, what does that do to our account?